Welcome, everyone. It is a pleasure to have you here for this session entitled Deploying Your Application, A Tale of Two Philosophies. Choosing the right deployment strategy is one of the most consequential decisions you will make for your project. Today, we are going to help you navigate that path, specifically focusing on client-side rendered applications. We will be conducting a comparison between two fundamentally different approaches: the streamlined, developer-centric experience of Vercel versus the robust, highly configurable power of Azure Kubernetes Service, or AKS. Whether you prioritize speed to market or granular control over your infrastructure, our goal is to help you determine which philosophy aligns best with your application's long-term goals. At its core, the objective for any client-side rendered application is fundamentally about serving static assets, HTML, JavaScript, and CSS, to the user's browser. While the goal is consistent, the methods used to achieve it are worlds apart. This comparison highlights a fundamental choice between a platform-as-a-service philosophy, exemplified by Vercel, and an infrastructure-as-a-service approach, represented here by AKS. Vercel is built specifically to optimize this modern web workflow, making the deployment of front-end assets seamless. In contrast, AKS treats your application as a containerized workload that just happens to serve files, requiring a different level of infrastructure management and configuration. Choosing between them means deciding whether you want a platform tailored to the front-end experience or a generalized infrastructure that provides broader container orchestration. To compare our two contenders at a glance, we have Vercel on the left and AKS on the right. Vercel is built around a philosophy of managed velocity, where the primary unit of work is a Git branch or build artifact. It offers low complexity through a zero-config setup and includes a built-in global Anycast CDN. Scaling is automatic and request-based, while security is fully managed with built-in WAF and SSL. Its pricing model is usage-based, focusing primarily on bandwidth and seats. On the other side, AKS prioritizes customizable control. The primary units here are Docker images and pods, which leads to higher complexity as it requires expertise in Kubernetes, Helm, and Docker. CDN and edge features must be configured manually via services like Azure Front Door. Scaling is node and pod-based, managed either manually or through a horizontal pod autoscaler. AKS provides full granular control over security via VNets, private links, and RBAC, with resource-based pricing driven by VM instances and storage. To understand the true nature of a platform, we must look closely at its architecture. We will now trace the journey of code from the moment of a Git push through to the end user's browser. This visualization allows us to contrast two distinct deployment flows, highlighting the practical differences in operational complexity and the management overhead required for each. The Vercel path represents a straight line to the edge, creating what we call the Git to URL experience. By connecting your Git repository directly to the Vercel platform, your code is automatically deployed across a global edge network. This workflow ensures that every pull request generates a live preview deployment, enabling instant feedback. Furthermore, the complexities of the build pipeline, cache invalidation, and SSL configuration are handled entirely out of the box. By automating these critical infrastructure tasks, Vercel eliminates nearly all DevOps overhead, allowing front-end teams to focus exclusively on building exceptional products. The AKS path illustrates a standardized pipeline of managed components for deploying containerized applications. The workflow originates in the Git repository, where code and configuration are stored. This triggers the CI/CD pipeline, which handles the automated build process. Key steps include building a Docker image, often using Nginx to serve static files, and pushing that image to a container registry, such as Azure Container Registry. Following this, Kubernetes manifests or Helm charts are updated to deploy the workload into the AKS cluster. Azure Front Door then serves as the entry point, providing global load balancing and security. While this model is highly effective, it is worth noting that implementing preview environments requires significant custom engineering, frequently involving specialized tools like Argo CD and complex namespace strategies. To truly understand the impact of our choices, we must move into a deeper comparison across 4 critical areas. We will break down the specific trade-offs that matter most to technical leaders: developer experience, performance, security, and cost. Each of these pillars represents a unique set of challenges and opportunities that must be balanced carefully. Let's explore how these factors influence our strategic decision-making process. When discussing developer experience, we often face a strategic choice between frictionless velocity and robust pipeline engineering. On one hand, we have Vercel, which serves as the launchpad. Its primary objective is to facilitate maximum velocity for front-end teams. By utilizing zero-configuration builds and providing instant feedback loops through automated preview deployments on every pull request, Vercel empowers developers to ship code independently without the need for dedicated DevOps support. In contrast, Azure Kubernetes Service, or AKS, functions as the blueprint. The focus here is on integration within a larger, highly controlled enterprise ecosystem. This path requires a more rigorous engineering process, including the management of robust CI/CD pipelines, Docker expertise, and the maintenance of Kubernetes manifests. While it involves more complexity, the benefit is the total control and architectural consistency it provides for organizations already standardized on Kubernetes. Ultimately, the decision rests on whether a team prioritizes rapid, autonomous deployment or deep integration and environmental governance. Let's look at how global delivery is handled by comparing Vercel's built-in edge to a more traditional bolted-on CDN approach, like we see with AKS. On the left, we have Vercel, which we refer to as the launchpad. Its architecture is designed to be global by default. When you deploy, your application is automatically distributed across a global edge network. From a user experience perspective, this is a significant advantage. Whether a user is in London, Tokyo, or New York, they are served from the nearest point of presence, or POP. This minimizes time to first byte and ensures world-class performance right out of the box with no extra configuration required. Now compare that to AKS on the right, which acts more like a blueprint. By nature, Kubernetes clusters are regional. If you deploy a cluster in the East US, a user in Tokyo will experience high latency, as their requests must travel across the globe. To achieve competitive global performance, you are forced to manually layer and manage additional services, like Azure Front Door or Azure CDN, on top of your AKS load balancer. The ultimate result is a trade-off in complexity. With Vercel, you get high-end performance instantly. With AKS, achieving that same global reach requires you to spend valuable time configuring and managing significantly more infrastructure. When we examine the overhead of serving static files, it becomes clear that for a client-side rendered application, using Azure Kubernetes Service is often an unnecessary expense. In a typical AKS setup, you are running an entire Linux kernel, a Docker runtime, and an Nginx process just to deliver a single JavaScript file to a user's browser. The fundamental issue is that you are paying for compute to do a job that simple storage could easily handle. With AKS, you are paying for memory and CPU consumption even when no one is visiting your site. You are essentially paying for idle compute. Compare this to a serverless static hosting provider like Vercel. With this model, there is no idle cost for servers. You only pay for the actual build time and the traffic your site generates. This approach shifts the focus from maintaining infrastructure to simply serving content, providing a far more cost-effective solution for static assets. Let's examine security and compliance through the lens of a managed platform versus enterprise hardening. On one side, we have Vercel, which acts as a launchpad. It is essentially a public platform that simplifies security by providing managed DDoS protection and a built-in web application firewall. While this is highly effective for many use cases, it can become challenging if your application must interface with backend APIs that are IP whitelisted within a private virtual network. Addressing this typically requires moving to enterprise-grade features. Conversely, Azure Kubernetes Service serves as the blueprint for enterprise-level control. This is where AKS excels, as it provides comprehensive enterprise hardening. It enables you to host applications within a private virtual network, utilize network policies to precisely restrict traffic flow, and leverage deep integration with Microsoft Entra ID for robust identity and access management. When evaluating infrastructure, it is crucial to understand how cost dynamics shift as your application grows. On this chart, we are comparing two distinct models: usage-based pricing, represented by Vercel in purple, and resource-based pricing, shown by AKS in blue. Vercel offers a low floor, meaning your initial costs are minimal, which is highly attractive for early-stage projects. However, it also has a high ceiling. As your traffic increases, the cost can scale exponentially due to usage-based metrics like bandwidth, which can cost $40 per 100 gigabytes on the Pro plan, alongside seat-based pricing that can become expensive at scale. In contrast, AKS operates on a high-floor model. You are paying for dedicated nodes even at zero traffic, creating a higher initial baseline. However, as shown by the flatter blue line, AKS provides a much more predictable ceiling. Because you manage the underlying resources, the cost per request is significantly lower when operating at a massive scale. The key takeaway is identifying the crossover point on this graph. While managed platforms like Vercel accelerate time to market with low initial overhead, there is a strategic point where migrating to a resource-based model like AKS provides superior cost efficiency and long-term financial predictability. To determine which platform best fits your context, we can use this decision framework to weigh the benefits of Azure Kubernetes Service against Vercel. Start by evaluating your existing infrastructure. If your CSR application is part of a larger microservices ecosystem already running on Kubernetes, we recommend choosing AKS. This allows you to leverage your established investments, existing tooling, and team expertise without introducing a new platform into your stack. Next, consider your security and regulatory landscape. If you are governed by strict compliance requirements, for instance, if your application must reside entirely within a private Azure virtual network, AKS is the appropriate choice. Its enterprise hardening features are specifically designed to meet these rigorous infrastructure standards. On the other hand, if your primary objective is maximum developer velocity and zero config global performance, Vercel is the superior option. It is highly optimized for the modern front-end workflow, enabling teams to deploy quickly and scale globally with minimal configuration overhead. If your situation does not align with these primary drivers, we suggest re-evaluating if AKS provides the necessary granular control for other unstated technical or business reasons. Choosing the right philosophy ultimately depends on balancing infrastructure consistency, security requirements, and your desired speed of delivery. Your deployment strategy serves as a direct reflection of your team's underlying philosophy. This choice extends far beyond simple technical requirements. It is about strategically aligning your infrastructure with your team's core strengths, your product's specific audience, and your primary business priorities. Whether you are optimizing for raw speed to market, as represented by the rocket, or seeking deep, systemic control, like a detailed architectural blueprint, your deployment path defines how you bridge the gap between development and delivery. Ultimately, the way you choose to deploy should be a purposeful extension of your organizational values and operational goals.